Good morning, everybody. Once again, I am here with you for the next session related with the solid state physics. Paper number 13. Myself again, Dr. S.D. Chauhan, Department of Physics, Adarsh College, Hingoli. So, guys, in previous session, we have seen a little bit about the introductory part about the solid state physics. What is mean by the solids? What type of the solids are there? Now today we are also looking forward for the another part which is also related with the crystal structure and which is very important part of this fundamental thing. So in the previous session what we have seen, that is, let's look out what we have seen in the previous part. So for that, if you look at in the previous session, that was to be related with your basically as an what is mean by the your solid state physics. That is no doubt it is the physical it is the branch of the physics which deals with the physical properties of the solids, and inside the solids whatever the small atoms are there, electrons are there inside, related with that in deep study, that is nothing but to be your solid state physics. Also we have seen what is mean by the types of the solids are to be there, and that types of the, when we have seen the types of the solids, with that case we found that there are two types of the solids are there. One is the crystalline, that is to be here. Another one is to be non-crystalline. So first we have seen that what exactly to be as an crystalline solids are to be there. In the crystalline solids we have seen that it is the periodic or the regular arrangement of the atoms, that is nothing but to be your crystalline solids are to be there. And here these crystalline solids are also of two types, single crystalline and polycrystalline. As far as single crystallines are to be concerned, we have seen that single crystalline solids are those solids in which the regular and periodic arrangement is also there because it is crystalline solids, but the whatever be the regular and periodic arrangement is to be there, that is throughout the continuous throughout the end of the material. And related to that, the examples are your diamond, quartz crystal and mica is to be there. Secondly, the crystalline solids part is nothing but to be your polycrystalline solids. Now polycrystallines are those polycrystallines which are, again, it is crystalline form and that's crystalline solids. That's why again here this type of the crystalline solids or polycrystalline solids are those, there is a random arrangement of the crystallites, there is aggregate of random arrangement of crystallites, and that is crystallites are what grains, that is the somehow it will be triangle, square, rectangular, different types of the grains should be there. And these randomly arrangement of the such aggregate of random arrangement of such type of the your crystallites are nothing but to be called your polycrystallines. And examples are metals and your ceramics are to be there. Again, as the crystalline solids we have seen, the non-crystalline solids, no doubt there is not a regular and periodic arrangement, it is the random arrangement of the atom, that is nothing but to be your non-crystalline solids are to be there. And these non-crystalline solids having the example your glass, that is your plastic, and your rubber is to be there. This is all about the what exactly we have seen related with the solid state basic things. Again, the crystallography is nothing but to be geometrical study related with this your crystal structure is to be there. Moving forward, or we have also seen related with this crystal lattice and your basically related with the translation vector part, that we have seen it is to be as an what is mean by, as far as the crystal lattice to be there. Lattice is nothing but to be a simply net type arrangement is to be there, and in which that is arrangement of the atoms is to be there, that is your lattice is to be there, in which the very important factor is your what is to be as an your basically uh, point lattice, and as far as the space lattice is to be there. Now in this point lattice or the space lattice, we have to first understand what is the one dimensional, two dimensional and three dimensional lattice are to be there. When the atoms are arranged around only one axis, that becomes to be array, and that is called to be as an one dimensional lattice. As far as the atoms are arranged with respect to the one axis, there is another axis is going to be covered, that is called to be as a two dimensional lattice. When that is having the two vectors, when it is to be as in three vectors are to be covered, that is three dimensional case is to be there, that is nothing but to be a three dimensional lattice is to be there. Now in this case, the point lattice and the space lattice part is to be there. It is the arrangement of the infinite numbers of imaginary points which are having the your each point is having the its identical surrounding. That means identical surroundings we have seen in detail also, that identical surroundings is nothing but when the 2 points I can see that is having the similar view, that is appearance is similar from whatever the point I am looking for. If suppose r and r dash, that is also we have seen in detail. And the pattern unit, it is nothing but lattice contents in small groups, that is to be there. And with this case also we have seen that is what exactly the translation vector is to be there. Now in this case here, the important factor what we have seen in the previous session, that here is the two dimensional lattice is to be there. If you look at this case, here is the points r and r dash are the two points where the we can say r and r are called to be as in having the identical surroundings. If I look from the r point, it will looks like to be similar appearance as far as I am looking from the r dash. Now here if you look at the translation, what exactly meaning to be translation vector? If suppose the atoms arrangement along the x-axis, that is this is nothing but to be translation, it is repetition of your pattern unit we have written, that t is translation. Now as far as the solid is to be there, we have to take any point or any atom as an origin. With that case, as the solid is three-dimensional case, so we have to take into account that three particular vectors are to be there, that is a b c, that three vectors are to be there, that is a b c, x y and z axis is to be there. Now in this case, the whatever be the first point, if suppose I am taking any point as an origin, from that along the x-axis first atom, that is your a vector. From that same origin point along the with respect to the o point or first origin point, the with respect to that point whatever the along the y-axis, that is your b vector or suppose, and along the z-axis that is supposed to be as a c vector is to be there. And this is what the small unit that is going to be pattern unit, that is going to be repeated, and that is somehow it is called to be as an your translation, that is to be n1 n2 n3 are nothing but to be your integers are to be there. Here in this case also, in the previous session I told you that here the book I have written small r dash and small r dash and r is to be there, but actually it should be taken to be as an capital R and r dash is to be there. So this is what the r dash is to be formed with the r, that is r dash is output of r plus whatever be the transition vector is to be there. Now again the vector, how it comes to be vector, from origin point to the a, or along the ax along the x-axis, the first point, that distance and magnitude and direction that gives you the vector, and that's why it is called to be one vector. And that's why the translation or particularly translation word comes with the vector, that is what vector part comes with this case. So three vectors a b c are to be there. Now this is how the translation is going to be there. And as far as crystalline solids are there, this translation is going to be continuous. Now as far as the your translation vectors parts are to be there, we have seen the first transformation or the translation, sorry, it is to be as n t is given with the 0 a1 b1 is to be there. If you look at this same figure, here are the two cases where a1 and the your b1 part is to be there, here it is to be as an b vector. So this is one vector we are discussing about, or one translation, sorry, we are discussing about. In this case, if you look at this, here it is to be as an this part I am discussing right now. So this is the what exactly we are discussing, the first case where the first translation is to be there. And in this translation 0 a1 plus 1 b1, if suppose this one is the your integral coefficients are there. With this case, if the transition is going on continuous, pattern unit is going on continuously, and it will form the points r dash, and that is nothing but to be, again, r is formed with the r dash is always formed with the r, and that's why the r and r dash is nothing but to be having the identical surroundings, and that's what exactly the your basically the point lattice or the space lattice part is to be there. Now in this case, wherever the such type of the translation vector is going to be formed, which is with the having the coefficient integral coefficient integral coefficients are to be there, and that is how it is given to be as an called to be as an primitive unit cell, primitive, sorry, translation vector. And with this case, whatever be the another example, if suppose now the another transformation I am looking for here, it is this one, the second one transformation is this one. Here again the part is not written, that is r dash point is to be here right now, here it is to be the r dash at this stage. This is what the case where this r dash is to be there. So here it is to be the r dash case, and this one is the r dash at this stage. Now this r dash is at this point, if you look at this. Now here the translation is vector translation vector is to be very important. That is r dash is going to be formed with the translation r plus half a2 plus half b2 is to be there. That means non-integral coefficients are going to be used, and such type of the your translation vector with the your non-integer integral coefficients are to be there, then such type of the your translation vector, it is called as a your non-primitive translation. Why this factor is very much important, I have repeated in deeply, because with this primitive and non-primitive vectors or translation vectors, the next part which today we are going to learn, that is called to be as an unit cell, is very much important. So moving forward, as an your